Hello everyone. So in today's video you will learn about two membrane techniques which are commonly used for softening of water, which also comes under external treatment methods for purifying of water. So these are membrane techniques, means in this method we are going to use specific membranes for purifying water. They are also called as desalination of brackish water. They come under desalination of brackish water. So the water which contains high concentration of dissolved salts is called as a brackish water, and desalination is actually the process of removing those salts from it. And the most common salt which is present in water is mostly NaCl, that is sodium chloride. So there are two commonly used membrane techniques for desalination. One is electrodialysis and another is reverse osmosis. So we are going to learn about these two methods in this video session. Let's begin with the first, which is electrodialysis. So electrodialysis, it is the process of removing ionic pollutants from water using electrodes. Ion selective membranes and electric field is electrodialysis. Hence this is the name because we are going to use ion selective membranes and electric field and electrodes. So the word electro comes from this, and this ions which are present in water. So impurities in water are of dissolved salts, like we are considering here as mostly sodium chloride. So it has sodium ions and chloride ions. So when we are going to use electrodes, ion selective membranes, and we are going to apply electric field, these ions are going to move towards the respective electrodes. That means its movement is going to happen. So the word comes dialysis. So this method is called as electrodialysis. What is the principle? It is based on the principle that the ions present in saline water will migrate towards the respective electrodes through ion selective membrane under the influence of applied EMF. So let's understand this process with the help of a diagram. So this is the diagram for the electrodialysis process. As said, we have two electrodes. One is anode, which is positively charged. Another is cathode, which is negatively charged electrode. So this membranes which you can see here, which are having a charged ions attached to them, are the ion selective membranes. So this is one ion selective membrane which has negatively charged ions attached to it. This is another type of ion selective membrane which has positively charged ions attached to it. Okay, and to this system we are going to apply electric field. So this is the container having ion selective membranes and electrodes, and these are the different compartments of the container. Like you can call this as compartment 1, the middle one is compartment 2, and this is the third compartment. So let's discuss first about the ion selective membranes which we are using. So have a look at this, the first one, ion selective membrane, which is having negatively charged ions attached to it. So since this is having negatively charged ions attached to the membrane, it will allow only positively charged ions to pass through it. So therefore it is called as cation selective membrane. Okay, because cations are positively charged ions. Since this membrane, it is having negatively charged ions attached, so it will repel the negatively charged ions present in water. Like ions repel each other, oppositely charged ions attract each other. So this membrane, since it is having negatively charged ions attached to it, it will allow only positively charged ions to pass through it. Therefore it is called as a cation selective membrane. So I will write it down as C. This membrane, second one, which is having positively charged ions attached to it, so it will allow only negatively charged ions to pass through it. So I can call this as a anion selective membrane, because anion is a negatively charged ion. I'm calling it as anion selective membrane because it is allowing only anions to pass through it. Again, you can see this is a cation selective membrane because it is having negatively charged ions attached to it. So it will allow only the cations to pass. It is going to repel the anions. So this is again cation selective membrane. And the last one, as you can see, since it is having positively charged ions attached to it, it is again a anion selective membrane because it will allow only the anions to pass through. So in this arrangement of electrodialysis process, we can see there are two electrodes, anode positively charged, cathode negatively charged, and there are selective membranes placed alternately. So one is cation selective membrane, another is anion selective membrane. And to this arrangement, to this container, we are going to apply an electric field. So what happens first, we put water in these containers. The water which we need to purify, which we need to soften, we add it into these containers. As we apply the electric field, what is going to happen? The positively charged ions which are present in water will move towards the negatively charged electrode, and the negatively charged ions which are present in water will move towards the positively charged electrodes. That means the migration of ions is going to take place towards the oppositely charged electrode. So like consider if it is a positively charged ion, that is cation, it will move towards cathode because the cathode electrode is negatively charged. And if it is a negatively charged ion, that is anions, they will move towards the anode because anode is a positively charged electrode. So movement or migration of ions is going to happen as we are going to apply electric field. So let's consider each compartment once. Now let's consider the middle compartment, which is the second compartment. So here it is having feed water, the water which we need to purify. So it will have both the ions, anions as well as cations. So as soon as we apply electric field, the anions, negatively charged ions, will want to move towards anode. So this ion will want to move towards anode. So when this ion wants to move towards anode, first there is a anion selective membrane present. Since it is an anion selective membrane, it will allow the anion to pass through. The anion will come into the first compartment. Now from this first compartment, it will want to move towards the anode again. So the anion will come here, it will want to move towards the anode, but here is a cation selective membrane present. So cation selective membrane will not allow the anion to pass through. So this anion will remain in compartment 1. So all the anions which are present in compartment 2 will pass through the anion selective membrane into compartment 1, but will not go further because there is a cation selective membrane present here. So they will remain in compartment 1. Let's consider compartment 2 for the cations. So all the cations will start moving towards the cathode as the electric field is applied. So when they start moving, initially there is a cation selective membrane. So it will allow the cations to move to compartment 3. But then this cations will want to move towards cathode from compartment 3. So there is a anion selective membrane present. So this cations will not be able to pass through the anion selective membrane. So they will remain in compartment number 3. So what has happened from compartment 2, all the anions moved into compartment 1 and all the cations moved into compartment 3. So as a result of this, we are going to get pure water from compartment number 2, which we can remove. So the water is purified. Let's have a look at the first compartment. When we apply electric field, all the cations will want to move towards the cathode, but you can see when this cations will want to move towards the cathode, there is an anion selective membrane. That means they will not allow the cations to move. So this cations will remain in compartment 1. Also, all the anions which are there, negatively charged ions, they will want to move towards the anode, but here it is a cathode selective membrane present which will not allow the anions to move, so they will remain in compartment 1. So similar thing is going to happen in compartment 3. So the end result of this process is that we are going to get pure water in compartment 2 which can be extracted, while ionic water is going to be formed in compartment 1 and 3. So this is the complete process of electrodialysis method, in which we are removing salt content from the saline water. That is why it comes under desalination of brackish water.